So here we have the sensor we'll be using to take LiDAR data for the class for the duration of the semester. Beginning from the right, first we have the line laser emitter, which functions as the emitting element in our Lidar sensor. And then next we have an Arduino Uno. The Uno functions both as a power source for the laser, since it has a regulated 5-volt DC output, and later on will serve as a sensor and controller interface to actuate any subsystems that are additionally added to this sensor later on, and to provide accelerometer data to give angles for our measurements. Moving farther on, we have the Raspberry Pi, which acts as a central controller for the entire system. The Raspberry Pi is responsible for capturing images, for controlling the Arduino and any systems that it controls in turn, and for managing the camera. And the camera is the final component on our sensor. The camera is the receiver and is responsible for retrieving the data that is the data from the environment as influenced by the line laser. Now, the sensor bracket itself is designed so that it can be very easily 3D printed to be manufactured quickly and, in many cases, in multiple iterations in order to best facilitate prototyping. To that end, the bracket is designed with 2 flat surfaces so that it can be printed in 2 orientations in one piece, and additionally, though it's relatively hard to see in this case, all of the mounting pillars for the boards are conical so that they do not require any support structure. This allows the piece to be printed much faster and with much less plastic. And finally, in order to mount the camera, Pi, Arduino, and laser, for the Pi, Uno, and the camera, there are screw holes, though at the moment they are being pinned in place by amounts of 18-gauge wire. And for the laser emitter, it is pinned in place by a retaining screw, which is inserted into a threaded hole, pinning the laser in place.